Okay, hello guys and welcome to the third video in my course Learning Java, my free YouTube course. And today we will talk about what we need to do to get started, to actually start coding, because I know you are probably excited to start coding, but first of all we need to install a software, and the software is called the Java Software Development Kit. Okay, inside of that Java Software Development Kit there is the Java runtime environment, about which I will speak first, because it's very important you understand what a Java runtime environment is, at least on a very basic level, right? So the Java runtime environment, as you can probably guess just by looking at the name, is a software environment that allows Java applications to run on any computer or device. Okay. More technically speaking, the JRE consists, among other modules, of the crucial Java virtual machine, which is responsible for running the Java bytecode on any operating system. Yeah? And the principle behind that is called write once, run anywhere. You could also speak about system-independent compilation. Okay, I know these are a lot of terms you may not know already, so let me explain it to you. I think the most important concept is the concept of compilation and the concept of a Java compiler. Okay, so maybe let's think back to our Hello World example. Every programming language is in itself a sense of abstraction, a way of abstracting away from the from the technical details of your computer or operating system. Okay, because in the end, everything you see, every type of software is an interpretation of an on or off signal that gets, like, there are logical gates. It's very complicated in the end, but you have to realize that the computer doesn't understand what we are doing here in the way that a programmer understands it. Okay, in the end, everything gets compiled, okay, translated into machine code, and you can think of machine code naively for a second as just consisting of on-off signals, like a binary stream of data, 0, 1, 1, 0, 0, 0. Okay, but since we don't want to program by just writing out 1, 0, 0, 0, 0, 1, 1, 1. Okay, and since we also don't want to program in assembly, for example, which is like the most low-level programming language there is. Instead of doing like these low-level, or because we don't need to do these low-level operations ourselves, there is an abstraction, okay, and this abstraction, it just is a programming language. Okay, hopefully that made sense to you. But in the end, a compiler takes this human-readable code in any programming language that gets compiled, okay, and in the end, every programming language gets compiled, and turns it into machine code that the computer can actually interpret or quote-unquote understand, okay. And the program that does this translation is called a compiler, okay. And now we can talk about what I mean by system-independent compilation. By this I mean you have to think there are many, like on the most granular level of detail, okay? On the lowest level, there are many differences between different machines. There can be different operating systems for once, okay? This is obvious. It just, if you want to write a program in C, for example, yeah, you have to have in mind that if you want to compile it, you have to have in mind which operating system the program will use, okay? You can't just write a program in Z, for example, in Windows, then compile it into an executable, and then expect that to be runnable on Mac OS or Linux, for example, which are Unix systems, okay? So, but also, if you look at assembly, yeah, there are different variants of assembly, just depending on the CPU architecture, okay? So there are many, many differences, and these differences affect the way that the compiler translates the program into machine code, into bytecode, into code that is actually interpretable by the computer, okay? And Java, because we don't want to, as a programmer, okay, we don't want to be bothered by these low-level questions, okay? And I don't mean low-level in an insulting way, I mean low-level in a technical way, okay? We don't care about the CPU architecture if we want to write a business system, for example. We don't, ideally, we would even ignore the operating system for which we are, like, trying to write programs, okay? It would be ideal if I could write a program once and run this program anywhere, and it would be ideal if I don't have to, like, do different ways of compiling just because there are different operating systems, okay? And you can see we are right here at this little slogan, and this is Java's slogan, it's write once, run anywhere, okay? So Java is actually a programming language that you can run on any system, any operating system, as long as the Java runtime environment is installed, okay? So that's also very beneficial. When you, for example, compare Java to Z, this is a very big upside of Java. Yeah, so I hope you understood what a compiler is. I hope you understand roughly the process of compilation, which is just the process of translating a human-readable code in any language, programming language, into bytecode, into machine code, okay? Then I talked about that the concept of a system-independent compilation, and the slogan of system-independent compilation just is write once, run anywhere. I told you that Java compiles independently of the underlying operating system. And now you could ask yourself, but why? How does Java actually achieve this? And the answer is, on this like very basic level of thinking about stuff, right, is the Java virtual machine. It's a very important concept and interesting concept as well. As a beginner, you don't have to be bothered by what the Java virtual machine actually is. I will give you a rough primer now, and I'll be uploading videos about the JVM in the future as an addendum to this introductory part of my course, okay? In the end, you can think, the question is, what is a virtual machine, okay? The virtual machine is just like a simulated computer inside your computer, okay? You can, I think that's the best way of thinking about what a virtual machine is for now, okay? And what Java does, Java is like an abstraction, okay, over operating systems, because for Java there is no real, as a Java developer, there is no real difference between running your Java application on a Windows operating system or macOS, because there is like the simulated computer inside any computer that runs the Java runtime environment, okay? And that computer, that simulated computer, that's a virtual machine, is where the Java code is actually executed and ran, okay? So, and this is like a way of, so to say, encapsulating the Java code, okay? We are abstracting away from the differences between operating systems like Linux or macOS or Windows, and we simulate this little computer and this virtual machine, and this enables us to do system-independent compilation, and this obviously is a good thing when it comes to portability of software, okay? Hopefully that was clear. It's very difficult explaining these concepts on like a level that is still understandable for a beginner. So, and maybe one little additional point, any Java program is using for example, you know that every program takes up some memory in space, okay? And Java programs are taking up space in that virtual machine, so that it's taking up virtual space, okay? So it's a very interesting concept. We'll probably talk about it much further on again, okay? So, but I told you to install the Java Software Development Kit and not the Java Runtime environment, okay? And now you could ask the question, what is this Java Software Development Kit, okay? Firstly, as I already told you, the JDK. Inside the JDK, the Java Runtime environment is contained, okay? So it's a superset, a real superset of the Java Runtime environment. But additionally to the virtual machine and some other stuff, there are also things that we need as a developer, okay? For example, okay, now I have to talk about libraries, but for now you can think of a library as being a bundle of functionality, okay? And these libraries define the Java language, okay? For in Java, everything is an object, which means everything inherits from the object class, okay? And this object class is just a defined regular Java class file, okay, inside the standard library, okay? And this standard library, this library that defines the Java language, is only contained in the Java Software Development Kit, but not in the JRE, okay? So it should be pretty obvious, okay? Maybe to make it a little bit more concrete, let's think back to the Hello World program, okay? We have here class Hello World, public static variable, blah, 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 yeah? But here is an example of a functionality, or you could also say simply function, okay? We are calling the print line function, and we are feeding it the string Hello World, and it prints out Hello World, okay? And this program is in a way already pretty complex, because in order to communicate with standard output, okay, in order to actually print this out, to the screen, you have to interface with the system functionality, okay? And this is an example of a Java class, okay? So inside this system library, this is like the interface to the operating system, okay? To the virtual machine in a way. And inside that library, there are many different functions, okay? And without the Java Software Development Kit, without the JDK, we don't have any of these functions. We can't program in Java, okay? This is one thing, the libraries, but more importantly, inside the JDK is also the Java compiler. And I already told you what the Java compiler does. It translates this into machine code, okay, so that it can actually be run by the CPU. And this is why we need to install the Java Software Development Kit. I'm really sorry, this is already a bit long of a video, but this is important that you know these basic differences. So now let's come to the step-by-step guide. I won't show you this because I have Java already installed and I don't want to manually uninstall everything again. There are great videos on YouTube. This one, for example, I will post it in the comment section. Also a very great channel if you want to watch Java by someone who has not a heavy accent like me. You can watch this guy. But the step-by-step guide is the following. It's only 4 steps, okay? We go to visit the official Oracle website, and you may ask yourself, why are we visiting the Oracle website, okay? The thing is, Java was developed by Sun Microsystems, or systems, I always forget, and Oracle bought up Sun Systems, so in the end, it's like Oracle owns the Java language in a way, but there's also an open JDK, which indicates, okay, it's the Java development kit, which does not depend on like the Oracle distribution of Java. There are many different Java distributions. I would recommend you just downloading the real thing, so to speak, but you can also download JDK if you want to. I don't know what's going on here. 1 second. Okay, it's a little bit buggy. Okay, I'm on Linux right now, but just download this file, and I'm pretty sure, I guess you're on Windows, and I'm pretty sure you can do it on your own, and if you have any questions, just Google it, or ask in the comment section. I'll be reading the comments anyway. So okay, let's go back to Obsidian. After you download it, you have to install it, of course. It's trivial. And after you did all the installing, and you open up your command line, in Windows this is just typing in cmd, okay? you can write Java version, okay, and something should show up here. For example, I'm running Java, the JDK, and the environment, the runtime environment of 21. Okay, maybe you chose another Java version. It doesn't matter in the end. Okay, of course it doesn't matter in some special cases, but yeah, something should show up here when you enter this command in your command line or terminal in Linux or wherever you are. Okay, our last word, and then we are done finally, and in the next video we can start coding. We need to talk about what an IDE is. Okay, IDE stands for Integrated Development Environment, and this is like a fancy editor for programmers. Okay, because you can imagine just what do you want to have as a programmer? I want to have, especially in a language like Java, I want to have auto-completion. Okay, I don't want to type out all this stuff manually all the time because this takes up time. But let's imagine, and I'll demonstrate this in the next video. If I want to write a hello world program, I would really like to, if I, for example, try to define the main method. Okay, I would really like to have, as soon as I enter P, I would like the auto-completion to suggest public, for example, so it gets like this. Okay. Of course, you would also want to, there should be some functionality in an editor that checks your code. For example, if you misspell something or if you are doing something which isn't technically not correct, your editor should warn you. Okay. And in general, an integrated development environment is just an editor for programmer with certain functionalities, which I will show you in the next from the next video on. And you just need it. It's I don't need to talk about this topic any longer. I think it should be pretty clear. And we will be using IntelliJ IDE, not Eclipse. I don't understand why people use still Eclipse. And you can download the IntelliJ IDE right here. There's a community edition which is totally free, and it's a great editor, especially for Java. So I wouldn't recommend, for example, using Visual Studio Code for Java, because Java is just, it's a peculiar language in that respect. So you need specialized editors, okay, like IntelliJ IDE. Let's click on it so I can show you. Okay, just download this executable if you're on Windows. Yeah, I'll trust you. I trust that you can do this on your own, and if you have any questions, you can always ask in the comment section. All right, that's it. Thank you for listening to me, and in the next video we will finally start coding, and we will actually run this Hello World program. I know you're probably sick from seeing this Hello World program, but things will pick up very soon and very quickly, and yeah, that's all I'm gonna say. So see you in the next video. Bye bye.